Hi guys, welcome back to my channel Vigyan Jyoti. So the topic today is combination of resistors. So we have come a long while, right? Where we were discussing about resistors, resistivity, resistance. So resistance is the obstruction that is offered to the flow of current. Resistor is the can say the device, or you can say the an object that offers resistance. And if it's fixed, means if the obstruction is fixed, then we will say resistance. If we say the obstruction is like we can change the obstruction, then that device is known as, or you can say the electrical component is known as rheostat. Okay, so that is what. Okay, next, resistance. We have found out three types of materials: conductors, resistors, insulators. Conductors, minimum resistance, or you can say negligible almost. Insulators is infinite, so the average between them is the resistor, who is offering some resistance to the flow of current, right? Okay. So one resistor application, we have fan. Okay, we control from 0 to 4. So in 4 we see the speed of the fan is high, and in 0 it's almost done. That means we offer the resistance to the flow of current. As a result, the minimum amount of, you can say, not, because minimum amount of current is flowing such that is not able to rotate the fan only, means rotate the blades of the fan. As a result, the fan means we see the switch is on, but the fan doesn't work. But as soon as we increase the speed of the fan, it works, because the resistance out there becomes minimum and current flows. As a result, we are able to feel the speed of this fan. Okay, so this was, and then we also found out that resistance is basically depending on, resistance is a constant that came from Ohm's law, but it does depends on various factors like the length of the conductor, the area of the cross section of the conductor, as well as the material of the nature of the material, and the temperature. So these all things have been covered so far. Now the question comes here. We were talking about the resistor, we were talking about the resistance, we have also talked about the resistivity, how are they related, everything. But what is their use? What is the application? So now each and every electrical appliance that we see around us, every electrical appliance has resistance. Every electrical appliance has resistance. Now, if they have resistance, why do they have resistance, and how are they connected in our household circuits or domestic circuits? We have to go through this now. Okay, so before understanding how they are fabricated in the circuits, in the electrical circuit, how they are kept, first of all we have to know the design. Before that, we have to know that how can we combine the resistors in two different ways. So first way is resistors. Okay, now when we talk about the first way we are talking about is series. So in series, what do you mean by series? Series means one after the other. Fine. So now if we have a resistance like this we have a resistance. Let's say this is R1, this is R2, and this is R3. Now this resistance can be same also, the resistance can be different also. Fine. So series means when we place the appliances with these resistors, that is what with this resistance R1, R2, R3, they are placed one after the other, and we are able to find out the overall resistance. Fine. Now how are we going to find out? Let's see. Now we give an overall voltage, means V, to the means we give a potential difference V. Fine. Okay. Now when we give a potential difference V, now first thing, let's say if you bring a unit positively charged particle here, positive, negative, whatever it is. Now to bring from this terminal, obviously at various points there will be different voltages, because across these 2 points the voltage will be different. Again across these 2 points the voltage will be different. Again across these 2 points the voltage will be different, right? Because after all you have to see how much you're working towards. So that means we can say here we can have the voltage as V1, V2 and V3. That means we understood this much, that when we try to do the work, when we try to create the electric potential, or let's say if we want to calculate the electric potential, we know at various points it will lead to various potential values, right? So as a result my voltages will be overall distributed. Which voltage will be distributed? The voltage that is here, it will be distributed to the various resistors. Fine. Now from Ohm's law we know that V is equals to IR. Fine. We are seeing it's changing. We are saying V is also variant. Now what about the current? This is also changing? No, because the current that originates from the voltage, right? The current always originates from the voltage. Now when the current originates from the voltage, means after all the potential, as soon as you put the potential difference, then only your current starts flowing. So after that means your current will flow from this direction. That means you have the I. Now this I, if you see, these are what? Flow of electrons. Now when there's a train of electrons going through each and every station, do you really think every station is seeing different amount of electrons? No. After all, it is seeing the same number of compartments of the train. Same way also here also the resistors which are present here, they are seeing the same number of electrons. Okay, we know electrons neither can be created nor can be destroyed. Then what is happening? The electrons are getting used, they are just transferring the energy to so that it may glow or it may get heat up. Okay, and then it starts flowing. So because the electrons need to complete the circuit, otherwise the current won't be, means if the circuit is not complete, how will the current flow, right? So that means current is same in all these cases. Fine, the current is same in all these cases. Fine, so that means we have the total voltage as V, right? Total voltage as V. Total voltage as V, and if I distribute this, since this voltage has been distributed, it's after all V1 plus V2 plus V3. That means if you're bringing one charge particle from this point, it will be V. Again from this point, it will be V2, V1. Okay, in this way, means just trying to give you one vision that at different points there will be different potential difference. Okay, now V1 plus V2 plus V3. Okay, now I can substitute it with IR1, IR2 and IR3. How did I do this? Because we know that the potential which is there, it is changing, R is changing, but I is kept constant, means I is same. So that means from Ohm's law, we got this, that V equals to IR. Now I can substitute this V saying IR EQ. EQ as in what? Equivalent resistance. Okay. Fine. Now we will take I as the common. R1 plus R2 plus R3. So now I and I gets cancelled. So remaining we have equivalent resistance as R1 plus R2 plus R3. Did you understand? My voltages are different because at various points there will be different voltages. That means the voltage has been divided into the various voltages. Next, the resistance may be same, may not be same. That depends on the electrical appliance. But the current, the number of electrons that have been encountered by each and electrical appliance will be same. Okay, so that's the reason my current is same throughout. Fine, clear this part. So equivalent resistance, if we want to find, we have to find it in this way, that is the summation of, now it is not necessary you will always have 3 resistors, you may have more than 2, means starting is 2. So if it's series, it was 2 resistors, let's say R1, R2, then just summation R1 plus R2, R1 plus R2 plus R3, R1 plus R2 plus R3 plus R4. In this way it continues. So it's a normal cumulative process where you are going to add all the resistance. Fine. This is how we find the equivalent resistance in series. Okay, now we will go to the resistance that we will do once they are connected in parallel. Okay, now we are going to a situation where the resistors are connected. How? They are connected in parallel. Fine. So let me draw. So this time the drawing will be like this. Since they are parallel, that means they are not going to meet, but yes, definitely the terminal is going to meet, because after all they will be connected to a single common battery. Okay. Okay, clear? Now here we have the voltage. Fine. Now you may see in this factor they will be R1, R2 and R3. Okay, if you see in this case, if you're bringing any charged particle to this particular point, after all the root is means if you see there's an alternative to the root. Fine. First of all, we know the current is going to go in this direction. So now when the current comes here, that means the flow of electrons, don't you think the flow of electrons will get divided? That means the current gets divided, means electrons comes in this direction. Don't you think the current will get divided? So the first primary thing that we are going to first write is that current. Let's say this is I1, I2 I3. Now initially some current was going through, so let's say the original source of current was I. That means we have understood this much, that in this case my current gets split up. So the summation of the current is I1 plus I2 plus I3. This much we have understood. Now the common thing, like, is it so the potential is also different or it's same? Let us see. If the potential is, it will be same. Why? Because after all you're bringing the charge particle either to this place or whatever. After all you're considering, let's say at this point what is my voltage? Let's say you're trying to find out the potential difference. Let's say you want to find out the potential difference across these 2 points. What to say? Out here the voltages will be different, okay, not here until unless you don't put resistors, but across this point, whether you are considering from here to here, let's say, that means you are just consider, that means the current will flow from this, that means one potential. Okay, if the current flows from here, then this part. So that means for voltage you have the alternative, fine, you have the alternative route. So for that reason the voltage is fixed. Again I repeat, the voltage is fixed, means I mean to say the voltage is common to all of them, because when you are considering to bring a unit charged particle from this point to this point, I will consider only this point to this point, I will forget about this two. That means the whole of the voltage will be used up here, right? Again the same story, either you consider this path or this path, after all again we know that it is being used, right? Because when we are considering with these 2 points, we forget about these 2 points, because after all the current, when it's moving through here, we will consider only this potential. When the current will everyone is moving at a time, means all the three means all the 3 wires are having flow of current, but when we are trying to calculate the potential difference, so at this point only these 2 points we will consider, and we will see how much current is what is the electric potential across these 2 points, right? So these 2 points and these 2 points do not meddle up, or the path is completely different, because the electrons which is traveling here is not the same electrons which are traveling there, fine? So voltage is the same thing, current is getting speeded up, hence current is different. So voltage is same. Now, so V1, now I1 I can substitute by V by R1, V by R2 plus V by R3. Now we know potential is equal to IR. Understood? Okay. That means it's V by R. Fine. Next, V, that's 1 by R is equal to 1 by R1 plus R by 1 by R2 and 1 by R3. Okay. Now, okay, anyways, I'll write it later. This is V. Fine. This V and this V gets cancelled. So R equivalent resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now what, and the answer you will be getting, we need to reciprocal it to find out the equivalent resistance. Okay. So this is how we have to understand when the resistors are connected in series, who is fixed or who is the same that is encountered by each and every resistor. Here also the same story. In parallel, in parallel also the same case. Which factor is remaining constant, because we know that when we are considering the potential difference between these 2 points, this should not meddle with the first one or the third one, right? Because after all we are considering only how much work done. But when we are considering with the series, if you are considering with this point, after all, if the electrons are coming through this direction, we have to consider these two resistance factors also, means the voltages also, that how much amount of the work already has been done. Fine. So for that reason, in this case current is constant, in this case voltage is constant. So and resistance will be given. Okay. So this is how we have to find out the equivalent resistance in series as well as in parallel. Clear? Okay. Okay. Now we will come here with some numericals. We'll come here with some numericals. First of all, okay, let me change the color. If 5 resistors each of value 0.2 ohm are connected in series, what will be the resultant resistance? Fine. So first of all, you have to find out how are they connected. They are connected in series. Fine. And how many resistors are there? There are total 5 resistors. Clear? That means we know that equivalent resistance is equal to R1 plus R2 plus R3 plus R4 plus R5. Now hence, since all of the resistors are same, that means we can replace as R plus R plus R plus R plus R. How many R? 5. That means total there are total 5 R. Clear? That means total there are how many R's? Total there are how many R's? 5 R's. Clear? Now in this question, here R's value is how much? 0.2 ohm. That means my total equivalent resistance will be 5R. That means 5 into 0.2. That means 5 into 10. I'll just delete this part. That means 1 ohm. Clear? That means how many, what is the equivalent resistance? 1 ohm. That will be the equivalent resistance. Fine. So see, if you are adding up so small resistance, it is total, the total resistance of the circuit is becoming 1 ohm. Okay. Now let's go to the next question. Same question, but this time they are connected in parallel. Same question, but this time they are connected in parallel. So what will we do? We know equivalent resistance is equal to 1 by R1. Fine, we have done. Now since my resistance all are same, so I will replace it with R. Total 5. So, okay, now LCM will be R itself, but numerator will be 5 because there are total 5 resistors. Means 1 plus 1 plus 1, so it becomes now now we have to reciprocal them. So R equivalent resistance is equal to R divided by 5 ohm. Clear? Now the question is, we will represent it by, we will change it to 0.2 divide by 5. So 2 divided by 50. That means 25, and it will be 0.04 what is that? Ohm. Clear? Understood? Fine. So that means you are able to see in series 0.2 had led to 1 ohm, means total resistance, means total resultant resistance. But when you connect them into parallel, your overall resistance will decrease. Clear? Your overall resistance will decrease. Okay. Next question. How should the two resistance of 2 ohms each be connected so as to produce an equivalent resistance of 1? So now whenever we see that, my overall resistance, whenever we see that my overall resistance is going to be less, we have a test, we get an essence that yes, this can be parallel. Okay. So we'll check that. So to get 1 ohm, that means, see, if I do like this, it's 2 and 2, it will become 4. So it's better we connect it into parallel. Fine. So it's 1 by 2 and 1 by 2, right? And this is my equivalent resistance. So how much will it be? 2 by 2, that is 1. And that means we will just do the reciprocal. It will become 1 ohm. Clear? Obviously here it's 1 by 1. And this is also 1 by equivalent. So it will become 1. So now equivalent resistance is equal to 1. Clear? Next. What possible values of resultant resistance one can get by combining two resistance, that is, one is of 2 ohm and other one is of 6 ohm. So if we do this one in series, that means 2 plus 6, it's 8 ohm. Clear? And if we do it in parallel, so 1 by 2 plus 1 by 6, that's 4 by 6. Okay, so what I'm trying to say is, sorry, this is my mistake. So this is my equivalent resistance. Okay, now we will find the reciprocal. It is 6 by 4. Is it fine? So LCM is 6 and 2 3s, 1s, 4 by 6. So then what will we do? Equivalent resistance will just do the the reciprocal. So 2's are 4 and 3 by 2. That means it's 1.5 ohm. Clear? So that means if we combine them in parallel, we are getting less resistance, and when we are combining it in series, we are getting a greater resistance. Clear about the series and the parallel? So what possible values of the resultant resistance one can get? So if I'm preferring series, I'll get 8 ohm, and if I'm preferring parallel, then I will get total 1.5 ohm. Clear? Okay, anything else? Oh, okay. A wire that has resistance R is cut into two equal pieces. The two parts are joined in parallel. What is the resistance of the combination? Fine. So, the thing is, we know that R is directly proportional to resistivity length and means directly proportional, better to say, it's a expression of resistivity length and area, right? That is what we know. Now here the question comes here that if it has a resistance R is cut into two equal pieces, means it's cut into two equal pieces. That means my length is getting affected, my resistivity means the material is not changed, that is mentioned, the area is not changed, that is also mentioned, but here the length has been changed. So if the initial resistance is like this and later on the length has become half, that means my new resistance is the half of the old resistance, right? So that means it is joined in parallel. That means if we have the two parts of the resistance, that means this is R by 2, this is also R by 2. Clear? Now they are saying what is the resistance of this combination. So that means 1 by R equivalent is equal to 1 by R by 2 plus 1 by R by 2. Clear? Now 2 by R plus 2 by R is equal to 4 by R. So this is my R equivalent, 1 by R equivalent. Now what is my, that means what is my resultant equivalent resistance? We'll just do the reciprocal, that means R divided by 4. Clear? That means if the wire has a resistance of R and if it is cut into two pieces and then joined into, two equal pieces and then joined in parallel combination, then the overall resistance will decrease by 1/4 of the original resistance. Clear? Is it easy? This is pretty easy, no? Just reciprocal, just don't forget to reciprocal that. Okay, next. A battery of 9 volt is connected in series with resistors, all this. How much current would flow through the 12 ohm resistor? Okay, so first of all, they are connected, how you have to see, they are connected in series. That means my overall equivalent resistance will be 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. Clear? So it will be 0.5 and see 0.5, that means 1 and 12 is 13.4. So total there is 13.4 ohm. Understood? Now, how much voltage is there? 9 voltage is there. You have to find out how much current is flowing through the 12 ohm resistor. Now, we know in series, if you just calculate the overall voltage, or you can say if you have the data, that means of overall voltage and overall resistance, then you can get the overall current. And we know in series overall current is only the current that is specific to each and every resistance, right? So that means I will find out the current like this. Overall my voltage is how much? 9, and equivalent resistance is 134 into 10. Clear? That means 90 by 134 ampere. Fine, this is the current that is flowing through the 12 ohm resistor also. Why? Because they are in series. Clear? Next. An electric bulb of resistance 20 ohm and a resistance wire of 4 ohm are connected in series with a 6 volt battery. Okay. So that means if I have a resistance of 20 and this is 4, since they are connected in series, I'm always confident of this part that I can draw it like this, but no, 6 volt. And this is 20 ohm. And this is 4 ohm, okay. Now, what they're saying, connected in series with a 6 volt battery, draw the circuit diagram and calculate. So, our circuit diagram is already drawn. Now, the first question, total resistance of the circuit. So, we know 20, I'm just taking some shortcuts, okay. 24 ohm, clear. Okay, next is B, current through the circuit. So, we know we have the overall voltage and overall resistance also. So, voltage is how much? 6, resistance is how much? 24. 1 by 4. So that means we have how much current? 0.25 ampere. Make sure you don't say 0.25. It's 0.25 ampere. Clear? So current through the circuit is how much? 0.25 ampere. Where is it? Total resistance, it's done. Current through the circuit is done. Now, potential difference across the electric bulb. Now, this is my bulb, right? I have done a mistake. that I have drawn resistor in fact, but when we are doing some circuit diagram, no, whenever we do circuit diagram, you always have to use the symbols that are used in the electrical circuits. Fine, okay. So this is bulb is 20 ohm, no? Okay, fine. So what am I supposed to say? 20 ohm, clear? Now the question they are asking, the potential difference across the electric bulb. That means we have to find out the potential difference across the electric bulb. Okay, now what is that force? Let us see. So resistance of the bulb is how much? 20 ohm. Clear? We know current is same. Current is same. That means I is how much? 0.25 ampere. That means my voltage is IRB, means current, and we know this is what is my current? 0.25 into how much? 20. Because of this 100 is coming, 25's 55. That means 5 volts. Fine. 5 volts. Out here it will be 5 volts. Clear? That means here it will be 100% 1 volt. Let us see how. We have to get 1 volt. Okay, let's see. That means, oh, they have already asked that the potential difference across the resistance wire. So I'll solve D here. Okay, that means we know the current. We have to find out what the voltage. No, that means V equals to IR. I is how much? 0.25. And what is my resistance? My resistance is 4. Clear? My resistance is how much? 4. So it will become 100, 25, 25, 25. That means total 1 volt. Clear? See, we have how did I find here 1 volt? 6 volt is the total voltage, 5 volt taken, so 1 volt is remaining. Clear? Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Jyoti, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment because your feedback does matter.